Welcome everyone to the IAPP web conference, The Browser Blind Spot, Why Data Privacy Often Comes Too Late, sponsored today by Jscrambler. Participating in today's web conference will automatically provide IAPP certified privacy professionals who are the named registrant with 1 CPE credit. The recording and slides will be available on our website under the resources tab within 48 hours. We encourage you to submit any questions you have for the speaker through the Q&A feature, as we will be saving time at the end to address those. With that, I will now hand it over to our speaker, Gareth Bowker, Jscrambler's Head of Security Research, to kick off the program.
Thank you, Selena. Hi, everyone. My name is Gareth Bowker. I'm Head of Security Research at Jscrambler. And I just wanted to mention as well, before joining Jscrambler, I was actually responsible for all things privacy at the PCI Security Standards Council. So I've actually spent several years in that DPO type role. So today, we're going to explore something that I think is probably one of the most under-examined areas in privacy governance, what I'm calling the browser blind spot. So specifically, we're going to be looking at where governed data actually begins and why the answer might not always be where your privacy program assumes that it is. So what I'd like to do is start with a positive acknowledgement. So the privacy profession has made enormous progress over the past several years. If you look at any mature organization today, you'll find investment across the board, whether it's data mapping exercises or privacy notices that actually reflect processing activities, consent management platforms, vendor risk assessments, governance frameworks that actually align to regulations. So these are all real substantive programs. And that maturity model on the right should look familiar to many of you. Organizations have moved up through the layers from raw data collection and ingestion through storage and processing into governance and quality controls. Some are operating at the analytics and insights layer using privacy-aware approaches to data science and business intelligence. But there's a question that I think deserves more attention. Right data actually, because if your governance controls are designed to kick in at the processing layer, or even at the collection layer, as most organizations define it, there may be an entire category of data exposure that sits underneath. And that's what we're going to explore in this talk. So this is a simplified version of how many privacy programs think about the data lifecycle. A user interacts with your service. That interaction reaches a collection point. That could be a form submission, an API call. It could be a payment transaction. The data flows into processing systems, eventually lands in the storage, and then governance controls are applied across those stages. Now, this model works well, and it's the basis of most ROPA entries, most data flow diagrams, most privacy impact assessments. And for systems of record, so your CRM, your HR platform, your payment processor even, it's pretty accurate. Those systems receive structured data through defined collection points, and you can apply controls accordingly. But the challenge is that most digital systems don't always follow this neat flow. There's an entire layer of data activity that occurs before that collection point, before that form gets submitted, before the API call fires, or before the transaction is made. And that's the layer that we're going to be talking about. So this is the core concept. In modern digital systems, data doesn't just appear at the point of submission. It's actually created continuously during interaction. Every time a user types into a form field, enters a search query, clicks on a link, or navigates between pages, that is data being generated. And critically, that data exists inside the browser or on a user's device before it ever reaches your backend systems. And if you look in the diagram on the right there, the user is filling in a form. So name, email address, phone number. The traditional view here would say that data is collected when they hit submit, and then it flows from the user's web browser to your web server, into your database, into your analytics pipeline. But the activity that's taking place in the browser, the typing, the hesitations, the corrections, the field interactions, it may already be accessible to technologies that are running on your page as well. And this distinction between data at the point of submission and data during interaction is fundamental to everything that follows. So before we go further, I want to make sure that we're all working with the same mental model, because I think the term client side gets thrown around a lot. So on the left, that server side, this is the world that most privacy programs are built around. So this is code that's running on infrastructure that you control. It could be your cloud environment, your data centers. You own the logs. You set the access controls. You define the rules ultimately. If something goes wrong, you can investigate because you've got observability. On the right-hand side there, this is the client side. This is the web browser or maybe a mobile app. Code written in a language called JavaScript runs on the user's device, in a browser, in an environment that your code shares with every other script that you've loaded on the page. You don't have the same level of logging. You don't have the same enforcement mechanisms. And while you can request that the browser enforce certain policies, things like content security policy headers, for example, the browser is ultimately under the control of the website user, not you. So when we say client-side technology throughout this talk, we mean here code that's executing on the right-hand environment here. So it's not on your servers, it's in the user's web browser. And that distinction matters because governance assumptions that we make about the left-hand side don't automatically transfer to the right. So what happens when someone loads your website? And the short answer here is a lot more than just the content that gets loaded. So some stats here. 92% of websites use some form of third-party JavaScript, meaning code that's loaded from somewhere that isn't your website. It isn't under your direct control. And for e-commerce sites, over half of the JavaScript executing in the browser comes from third parties too. So that's not your application code. That's analytics scripts, advertising pixels, tag managers, session replay tools, consent platforms, chat widgets, and increasingly as well, AI tools. And here's the critical part. Each of those scripts runs in the same execution environment. So the web browser here doesn't isolate them from each other by default. There's no sandbox wall between your analytics script and your advertising pixel and your session replay tool. They all have access to the same DOM. That's the same page structure, the same form fields, the same user interactions. And this is by design. It's what allows third-party scripts to add a pretty navigation control to your website, or allows the magical auto-completing address lookup that you sometimes see. It allows that to work. But equally, as we'll see shortly, it's also what allows these scripts to access data before your governance controls kick in. So when you include a third-party script on your page, you're not just adding a feature. You're also granting that script the technical capability to observe everything that your user does on that page. Whether it exercises that capability is a separate question, but the capability is there by default. So let's look at this more precisely. The browser here sits in a uniquely privileged position. It's the first point of contact between the user and your service. Before any data reaches your backend, before any API call fires, the browser sees everything. And again, that's not necessarily a bad thing, it's just how it works. They collect that data. that information before sending it your way. It can observe form entries as well. So not just the final submitted value, but each keystroke as it happens. The auto-completing address lookup that I mentioned, that's exactly what it's doing. It's looking at those keystrokes and it's responding in real time. And it improves the user experience of your website, having it work like that. It can observe clicks and navigation, what the user looked at, in what order, how long they spent on it. It can observe behavioral signals, scroll depth, mouse movement, hesitation patterns. And it can observe sensitive data, financial details, health information, personal identifiers as they're being entered. Now, if you look on the right-hand side of this slide, all of those technology categories that we just discussed, all of those third parties adding advertising pixels, your marketing team wanted, your analytics scripts, the payment integrations, customer experience tools, or even AI assistants, they're all operating in that same shared environment simultaneously with access to the same interaction data. And this is the environment that most privacy programs have limited visibility into. So your server-side logging telling you what data was submitted, it doesn't tell you what was observable in the browser during that interaction. Now, this slide puts the gap side by side. And if you take nothing else away from this talk, I hope it's the information that's shown here. So on the left-hand side, this is what privacy programs typically expect to govern. Name, email address, payment information, physical address, account identifiers. This is what your data map covers. This is what your ROPA describes. This is what your privacy notice talks about. And then on the right-hand side, this is what may actually be accessible during interaction before the user hits submit. So email addresses as they're being typed, character by character, phone numbers or digits as they're being entered, physical address fields as they're populated, search queries, product selections, authentication events, the form entry before submission. And the distinction isn't subtle. The left-hand side here represents data that your organization has deliberately collected and can account for. The right-hand side represents the data that is technically observable by any script running on that page. And this is the part that your organization may not even know is accessible. And look at the why this matters bit. This has implications for privacy compliance, obviously. If data is accessible and accessed before consent is captured, well, that's a problem. But it also has implications for competitive intelligence exposure as well, and I'll come to that in a minute. The question for everyone in this session: does your data map include the right-hand data elements or only the left? So, apologies for the slight formatting issues on this slide here, but this is what I call the consent timing gap. It's a structural problem. So it's not a failure of any particular consent tool. So if we walk through this timeline, step one, user lands on the page. As soon as that page loads, scripts begin executing. Step two, the consent banner appears. So by this point, the user is already in an environment where scripts are running and could be observing. Step three, the user interacts with that banner. They click, they scroll, they read the options, and that interaction itself may be observable to scripts that are already running. Step four, the user makes a choice. They consent or they don't, they reject it. And this is where governance formally starts. Step five, the user fills in a form and submits. And this is what most privacy programs consider to be the moment of collection. If you look at the gap between that first step and the fifth step, that's potentially a blind spot. Your governance framework assumes that collection happens at stage 5. But the technical reality is that observation may begin at step one. And I want to be clear here as well, it's not necessarily a failure of your consent management platform. Most CMPs are doing exactly what they're designed to do. As I said, the issue here is structural. It's a characteristic of how browsers load and execute code. Scripts don't just politely wait for your consent before initializing. They execute when the browser parses them, which is quite often on the page load. Unless your organization has taken specific active steps to only load those third-party tracking or analytics scripts, or those AI chatbots after consent is obtained, well, you have a blind spot. So let's make this concrete as soon as it goes on to the next slide. Selena, I don't seem to have the ability to control these slides right now. There we go, thank you. So there are three scenarios here that are relevant to the types of organizations many of you work with. First is a healthcare portal. So here a user begins typing symptoms into a search field. Maybe they're looking for information about a specific condition, or they're searching for a specialist. Client-side scripts can observe each keystroke as it happens, before the user presses search, before any consent interaction, before that search query is submitted to your servers. That search query is health data. It's special category data under GDPR, for example. And it's potentially observable by the analytics script in the page. Second example here is financial services. Again, a user is entering income and a desired loan amount into a mortgage calculator or an affordability tool. As they're populating those fields, those values, again, may be readable by any script that's on the page. That's financial data. It could reveal economic status, borrowing intent, or financial capability. The user here hasn't actually submitted their application yet. They're just exploring, they're playing around with those little sliders and seeing what values come out. But the data is there, it's in the DOM, and it's accessible. Or an employment application on the right here. So a candidate fills in a diversity monitoring form, for example, disability status, ethnicity, veteran status. These are protected characteristics. And if the web page uses just a standard web form, these values, again, may be observable to scripts as the fields are being populated. Before submission, before the candidate has even decided to continue with the application. And these aren't just hypotheticals. This is how DOM observation works by default. And the question is, does your governance framework account for it? So the research here bears this out. When you actually audit what's running in the browser on a typical website, often many more than the organization's privacy, or legal team is aware of. You'll find dozens of scripts. As we've discussed, these technologies often observe page behavior, page activity, user interactions, form field behavior, navigation events. And remember here, they're often doing so before that server-side processing occurs. The data is accessible in the browser in real time as the user is interacting, and your server only sees what's explicitly sent to it. And this creates kind of an interesting asymmetry. Your server-side logs give you a record of what was collected, but they don't give you a record of what was observable. So the gap between these two things is the browser blind spot that I mentioned rearing its head again. What's particularly challenging is that the set of scripts running on your site isn't necessarily static either. Marketing teams deploy new scripts, or the pixel provider publishes a new version of their pixel code, and it's got some new data collection feature that is on by default. Product teams add new analytics. Tag managers get updated configurations. That browser environment changes constantly, and your privacy documentation or worse, your understanding of what's actually going on the page isn't necessarily keeping pace. So this slide shows kind of a real world pattern that most organizations, I think, will recognize. And I just want to walk through it carefully because this is often where that vendor oversight breaks down. So if you start on the left with your website, here it's loading two things. It's loading myapp.js and a tag manager, in this case, Google Tag Manager. So that's two things here that your development team has deliberately included. But then as we go over to the right on the slide, look at what's happening next. Your application code there is loading checkout.js and jQuery. Fair enough, those are your dependencies. You might have copied a static version of jQuery to your site so that you've got a better idea of exactly what it is that that script is doing, and to prevent any unannounced features or unannounced updates from breaking something on your website. But checkout.js, that's coming from your payment service provider, and that's under their control. That's probably fair enough, probably. You know, they're a regulated entity. Chances are they've got some pretty strict change control processes in place. But here they're also loading their own third-party script, or fourth-party, I guess, from OneTrust. And that's pulling in more scripts again. And you can see how, even with only a small number of initial scripts here, how it can snowball really quickly. And the lower half of this with Google Tag Manager, that container that you deployed for your marketing team, it's loading Google Analytics, TikTok ads, and then from there, several advertiser scripts. You may have approved Google and TikTok. You may even have DPAs in place with those vendors. But as you follow that chain further, those advertiser scripts may load their own dependencies. So advertiser 2 here is loading tracker.js. That's a sixth party script. So script loaded by a script, loaded by a script, loaded by a script that you deployed. I think I got that count right. Your legal team might have reviewed your privacy agreement with Google for GTM, maybe with TikTok for their ads pixel. But does your contractual chain extend all the way down to tracker.js? Do you even necessarily know that it's there? Now, this is something that we sometimes call piggyback tagging, and it's a fundamental challenge for vendor management. If you're doing GDPR, then your Article 30 records may list 10 processors, but there could be 30 scripts executing in your user's browser, and only a fraction of them are in your vendor register. So let me try and translate that into that technical reality into governance language, because these are the 4 risk areas that I'd encourage you to assess. First is contractual coverage. So if a piggyback script is executing on your site and it's processing personal data, but you don't have a DPA with that vendor, or you don't even know that they're there, you've got a gap. Under GDPR, the absence of a data processing agreement for a processor is a compliance issue. It's not just a best practice miss. Second is purpose limitation. And this one's particularly tricky. You deploy a script for analytics, page views, session duration, conversion tracking. But the vendor's code may also collect data for ad targeting or for feeding an ad network. You authorized analytics, but they're also doing something broader. The purpose that you disclosed in your privacy notice may not match the full scope of what the script is actually doing. Third is data transfer. A client-side script could be transmitting interaction data to servers in any jurisdiction. It could be in the US, it could be in China, it could be anywhere. If that transfer isn't covered by your transfer impact assessment, then again, you may have an exposure here. But worse, because these transfers happen in the browser, they may not even show up in your server-side network monitoring. And then the fourth one here is vendor inventory accuracy. Again, for GDPR, if you've got Article 30 records, they would be listing server-side processors. But do they include every script that's running in the browser? I think for most organizations, the honest answer here is probably no. If your documentation doesn't match what's technically happening, then that's a defensibility problem. And I want to try to broaden the lens a little bit here too, because this isn't only a privacy compliance story, it's also a business risk story. And this is the framing that often gets the attention of the C-suites in the board. Think about what interaction data reveals beyond just personal data or PII. Search queries tell you what products a user is interested in. Pricing page interactions reveal price sensitivity. Are they lingering on an enterprise tier or on the starter plan? Feature comparison behavior shows what capabilities matter to them. Part composition and abandonment patterns reveal purchasing intent or hesitation points. And in B2B contexts, you could be exposing company identifiers, deal sizes even, and procurement signals. And here's the critical question. The third-party scripts observing this data often serve multiple clients. Your analytics vendor serves you, and they serve your competitors. Your advertising pixel provider is building audience profiles across their entire network. The data that's observable in your user's browser doesn't just stay with you. I think this really does a good job of reframing the conversation. It's not just, are we GDPR compliant? It's, are we leaking competitive intelligence through our website's client-side technology stack? And I think that's a question that resonates in the boardroom in a way that Article 30 accuracy sometimes just doesn't. So I want to connect this back to the topic that seems to be on everyone's agenda at the moment, which is AI governance. So AI-powered tools are increasingly deployed as client-side technologies, and they're subject to exactly the same browser dynamics that we've been discussing. They run in the same execution environment as every other script on the page, with the same access to the same user interactions. Okay, if you look at the example here. So imagine a support chatbot deployed on your site. That chatbot runs in the browser. As part of its operation, it may observe the user's form entries, their page navigation, their account details. And it uses all of this as a conversational context. It then transmits that data to an external inference API to generate a response. Now, your privacy notice might not mention this data flow. Your DPA with the chatbot vendor may not cover the interaction data that it can technically observe. And that example, I think, illustrates the three risks on this slide. So these tools observe page content and user interactions as inputs. They're the same DOM level access that we've been talking about throughout this session. They transmit data to external APIs and inference endpoints that sit outside of your infrastructure, potentially in jurisdictions that you haven't assessed. And they operate under the vendor's privacy policy, not yours. So your user is on your website, expects your privacy commitments to apply, but the AI tool here, the key question is at the bottom of the slide here, and I'd encourage you to take it back to your organization. If an AI tool on your site ingests user interaction data as input, is that reflected in your AI governance documentation? I think for most organizations I've spoken to, the answer is that browser deployed AI hasn't even been considered in that context yet. And again, that's a gap that regulators are increasingly going to ask about, which brings us nicely onto our next slide. So this slide grounds the AI governance point into specific regulatory frameworks. On the left, you can see the familiar ones, GDPR, CCPA, HIPAA. These are probably your established data governance frameworks, and they already create obligations around data exposure patterns that we've discussed. But I want to focus on the two on the right there, the EU AI Act and ISO IEC 42001. These are the emerging AI-specific frameworks, and they raise the bar significantly. The EU AI Act, and specifically Article 10, introduces data governance obligations for high-risk AI systems. That includes requirements around data quality and provenance for training and input data. And the key word there is provenance. If an AI tool on your site is consuming browser-level interaction data as input, then you need to be able to account for that data, where it came from, what it contains, how it was collected. And if your answer is, we're not sure what the chatbot can see in the browser, then that's not going to satisfy Article 10. For ISO 42001, this is the AI management system standard. And in this, Annex A controls, the Annex A controls are directly relevant here. It requires that organizations identify and document AI system data sources and to maintain traceability of inputs. So not just training data, the operational inputs too. So if a browser deployed AI tool is ingesting user interaction data as part of its normal operation, that needs to be documented and it needs to be traceable. If you can't trace the data feeding your AI tools back through the browser layer, then again, you've got a gap in your AI management system. And the common thread, this is at the bottom line of the slide here, is that both frameworks require organizations to trace data from its point of origin. So all 5 frameworks on this slide expect you to be able to an origin is the browser. If you don't have visibility into what's happening there, you have a traceability gap that spans both your privacy program and your AI governance program. So if you accept the premise that the browser is a significant governance surface that most programs have got limited visibility into, what questions should privacy leaders be asking? I think these 4 are a good starting point. When is data first accessible? It's not when it's first submitted, it's when it's first observable. That then reframes your data collection timeline. Which technologies operate in the browser? Again, it's not just the ones that your development team deployed deliberately, but it's the full chain of scripts, including those piggyback tags. When does consent occur relative to exposure? Is your consent mechanism genuinely capturing choice before scripts begin observation, or is there a timing gap? And what vendors have interaction level access? This goes beyond your server-side vendor register to the scripts actually executing on the page. Underpinning all of these is the question at the bottom there. Where should data enforcement start? If your enforcement starts at the server, at the collection point, you may be missing everything that's happening before that. And these questions strengthen audit defensibility. If a regulator asks how you govern data at the point of creation, having answers to those questions demonstrates that your program has considered the browser layer. And I want to give you something as well that's immediately actionable too. So these 5 questions are designed so that you can take them back to your organization and use them in your next vendor assessment or your next privacy review, or just your next conversation with your security team. Number 1 here, do we have complete inventory of all scripts executing on our web properties? So not just the server-side processors. As I mentioned, most organizations can tell you they're server-side vendors, but fewer can tell you every script that's running in the browser, especially when it comes to those 4th, 5th, nth party scripts. Number 2, which of these scripts can observe form field input before submission? So this gets at the DOM observation point that we discussed. Not all scripts read form fields, but some do, and you need to know which ones. Also, which safeguards are in place to prevent scripts that don't need form field access from getting it? And most organizations don't have anything here, unfortunately. Number 3, do our DPAs cover the data these scripts can technically access, or only what we intend them to collect? That's often there's often a gap here between the contractual scope and the technical capability. Your DPA might scope data processing to page view analytics, but the script technically has access to form field contents. Number 4, has our consent implementation been tested to confirm that it loads and captures choice before scripts begin observation? And that generally means before they're loaded into the page. I don't just mean documented here, I mean tested, actually verified in the browser. That consent timing gap that we discussed is not theoretical and it is testable. Number 5, are browser deployed AI tools included in our AI governance register? This is the newest question on the list, and for many organizations, it'll probably surface a gap that they haven't considered. Now, you don't need to be technical to ask these questions, but the answers will tell you where your governance documentation reflects what's actually happening at the browser level. And if those questions surface gaps, and in my experience, they usually do, here's how to scope the work to address them. So step 1, inventory. Start with your highest risk user journeys, registration flows, checkout processes, account management, anywhere that users enter sensitive data. Catalog every script and pixel executing on those pages, not just what your documentation says should be there, what's actually there. Step 2, map data access. So for each script that you've identified, determine what user data is technically observable versus what it's intended to collect. The gap between technical capability and stated purpose is where your risk lives. Step 3 is consent timing. So actually test in a web browser whether your consent mechanism captures choice before other scripts begin executing. Load the page, watch the network requests, see what fires and when. Now, this is a technical test, but it answers a governance question. Step 4 is contractual review. Verify that your DPA, that the coverage for that extends to all scripts with data access, including those piggyback scripts that we discussed, the fourth-party technologies loaded by your vendors. And step 5, documentation alignment. Compare your findings against your records, your privacy notices, and your AI register. Where the documentation doesn't match the technical reality, again, you found your gaps. And the key point at the bottom here is important. This isn't a one-time exercise. Your marketing team may deploy a new pixel next Tuesday. Your product team might add a new chat widget. Your script inventory changes constantly, and your governance needs to keep pace. We're seeing this shift already. Leading organizations, particularly in financial services, in healthcare and regulated industries, are beginning to incorporate client-side visibility into their privacy programs. And this means 4 things in practice. Client-side visibility, knowing what's executing in your browser, not just what's running on your servers. Vendor inventory at the browser layer, so extending your vendor register to include scripts and pixels, not just server-side processors. Interaction level data awareness, so understanding that data exists and is accessible before the submission event. And real-time control of third-party scripts. The ability to monitor and enforce policy on scripts executing in the browser, not just after the fact in server logs. So the governance stack diagram on the right shows roughly where this fits. Traditionally, the governance has operated from the application layer upwards. So processes, policies, organization, strategy. But there's a layer below, the web browser. And below that, the operating system, the hardware, the physical infrastructure. The browser layer has been missing from most governance models. And that's what we're arguing needs to change. The goal here is straightforward: aligning technical reality with privacy commitments. If your privacy notice says you govern data collection, that governance needs to extend to where it's first accessible, and that's the browser. So let me bring this together with 5 takeaways. Number 1 here, the browser is a privileged but low visibility environment. It sees everything that the user does. It's the first point of contact, but most governance programs have limited insight into what happens here. 2, third-party client-side technologies complicate vendor oversight. The delegation chain that we showed, from your tag manager to vendor scripts to piggyback tags, it means that your browser may be running code from vendors who aren't in your register and aren't covered by your contractual framework. Third point, sensitive data may be accessible during interaction at the point of creation, not just at the point of submission. That's a fundamental shift in how we need to think about that data collection timeline. Number 4, interaction data includes personal data and strategic competitive signals. So this isn't just a compliance issue, it's a business risk that touches competitive intelligence, pricing strategy, and customer behavior insights. And number 5, privacy governance increasingly begins in the browser. If your program doesn't have visibility into the browser layer, there's a gap between your governance commitments and your technical reality. And I'd encourage you to take the vendor assessment questions from a couple of slides back to your organization. Test your consent timing, inventory your browser scripts, and ask whether your documentation reflects what's actually happening. Now, I've touched on research a few times during this presentation. So I wanted to mention that the security research team here at Jscrambler, that's my team, published some new research just last week looking at exactly the kind of behavior that we've been discussing. The paper examines Meta and TikTok advertising pixels, 2 of the most widely deployed client-side technologies on the web, and what they actually do at runtime on real websites across retail, hospitality, and healthcare. What we found was that these pixels go well beyond ad attribution. They collect detailed product-level intelligence, product names, prices, quantities, cart values, the entire customer journey. TikTok's pixels were observed capturing physical addresses from store locator fields at a major European retailer and transmitting them back to TikTok servers. Meta's pixel included a feature called automatic events, which is enabled by default and which scans page elements to capture data, including cardholder names, the last 4 digits of credit cards during checkout transactions. And the consent dimension is particularly relevant to today's discussion too. In several cases, we observed data being transmitted before the site's content management platform had an opportunity to block it. And in some cases, even after the user had clicked reject all. That's the consent timing gap that we discussed earlier. It's playing out in practice with 2 of the largest advertising platforms in the world. The full paper is available on Jscrambler's blog. You can follow the QR code on the screen or go to jscrambler.com/blog and you'll find it there. I'd encourage you to take a look, particularly if your organization uses any of these pixels. And finally, before we get into the Q&A section, I just wanted to tell you a little bit about Jscrambler and how we can help with this topic. So Jscrambler has been working in the JavaScript security space since 2010. And it was one of the first companies to focus specifically on client-side protection. The platform has 2 core products that are directly relevant to what we discussed today. First of those is code integrity, and this protects first-party JavaScript. That's the application code that you write and you deploy. It applies obfuscation and runtime protection, and it makes your code resistant to reverse engineering and tampering. This is important because your client-side application code is, by definition, delivered to the user's browser. It's visible and it's modifiable. Code integrity addresses that exposure. And then web page integrity is the product that's probably most directly relevant to this talk. It provides real-time visibility of every script and network request executing on your web pages. So this includes those third-party and piggyback scripts that we discussed. It monitors their behavior. It tracks what data they access, where they send it. And it also enables policy enforcement so that you can control what those scripts are allowed to do. That's the inventory, that's the data mapping, data access mapping, and it's the consent timing validation that we talked about in the audit section. And it's delivered as continuous monitoring rather than as a point-in-time exercise. Together, these give you the visibility into the client-side layer that sits between your application and the governance controls that we've been discussing. And it turns the browser from a blind spot into a governed environment. So with that, thank you. And it's time for some Q&A. I've seen a few questions coming into the Q&A box on the side here. So Julia, what questions do we have?
Hi there. Yes, we have a couple of questions that are very interesting here. So starting with, we use a consent management platform and we've configured it to block scripts until consent is given. Doesn't that solve the timing problem you described?
Yeah, it's a good question. It's kind of the right instinct as well. So if your consent management platform is genuinely configured to block script execution, so not just cookie settings, but the actual script loading, and it does that up until that point that consent is captured, then yes, you've addressed the significant part of that timing gap. There's a couple of caveats with that though. First, blocking can mean different things, so check exactly what that means. I've seen some CMPs that block cookies, but they still allow the script to load and execute. So it just can't write to storage. But the script can still observe the DOM and it can still make network requests. And second, I've seen well-configured CMPs as well that have race conditions, meaning the page maybe loads slightly faster than the consent layer, and it creates a brief window there where the scripts can execute. And another point as well, the CMP configuration, it's only as current as the last time that someone reviewed it as well. So if marketing adds a new tag through Tag Manager, does it automatically inherit the right consent category, or does it just default to loading? And I think that the answer to that varies from implementation to implementation. So I guess, you know, if you've tested it, if you've actually tested it in browser, you've watched the network requests, you've confirmed the sequence, you're in good shape. If you've configured it, but you haven't verified it, then it's probably worth doing that exercise.
Thank you, Gareth. We have a couple of more questions. Do you know of any cases where piggyback scripts found a company in violation of privacy regulations?
I don't know of any public ones. I know of quite a few from speaking to various different companies. You know, I mentioned Jscrambler's web page integrity. This gives companies a lot of very insightful information about exactly what's being loaded. And what we see time and time again is that visibility is eye-opening. You know, companies suddenly see the full scope of all of the scripts that are being loaded, and they didn't realize that it was quite as widespread or quite as large a number of scripts as they were expecting. Mm-hmm. So there's nothing really that I can point to that says, you know, they may be caught violating privacy regulations, but definitely examples where companies have discovered areas where they definitely were violating, and they were then able to do something about it. In fact, the blog post that I mentioned as well, we talk about a few that they're anonymous, but the companies that are mentioned in there are real. We've spoken to some of them to let them know about the issues that we found. And one of them I know in particular was talking to one of the ad networks involved because they considered it to be a security and a privacy incident. A particular setting had been enabled that they weren't aware of, and it had started sending more data than they expected back.
Thanks again, Gareth. I think we still have some time, so let me read one more. How do you recommend we approach this with marketing teams? They're the ones deploying most of these scripts, and they tend to push back on restrictions.
Yeah, this is probably one of the harder organizational challenges, isn't it? Marketing teams are they're deploying scripts because ultimately they want to be able to measure business outcomes and drive those measures as well. So, what's the attribution, conversion optimization, audience building, those types of things. And I think it's very similar to the information security principles here too. Just telling someone within the company no, it just creates friction. And I think it's better to try to reframe it. So rather than saying you can't use that pixel, it's a case of saying, let's understand what this pixel can actually access. If you're showing marketing team that their analytics pixel can technically read credit card fields on a checkout page, they usually don't want that either, because it is a liability ultimately. And I think the competitive intelligence angle as well can help here too. So marketing teams care a lot about competitive positioning, and if you explain that the advertising pixel that they've deployed is sending that product level pricing and cart data that I mentioned to a platform that's also serving competitors, then I think that kind of reframes it from being a compliance restriction to maybe more of a business protection conversation. And I think practically then, I'd probably suggest involving marketing early in this. The earlier you can involve them, the better, because just presenting findings after the fact is jarring. It's that friction again that I mentioned. If you can help make them part of the solution, get them involved early on, ask you questions from that privacy perspective, make sure that it's working, make sure that it's only capturing the data that they want. I think that works really, really well.
I agree. Yes, I think we have time to one more. Selena, please, if I'm wrong, please interrupt me. But this is a very interesting one. If we can do it, if I've had a tool for basic analytics, but it's secretly feeding a TikTok or Meta pixel for ad targeting, who is legally on the hook for that unauthorized process?
I think, well, ultimately you are. That's the end case here. It comes down to who is the data controller. So I'm thinking about this from a GDPR perspective, but obviously it works differently elsewhere. Under GDPR, a website that deploys a script, they are the controller, or at minimum they're going to be a joint controller for any of the data processing that script does. Ultimately, you chose to include it on your page. You're the ones making it available to your users. The fact that the vendor's code did things that you didn't expect or didn't authorize, it doesn't remove your accountability. And I think there's some case law about this as well. I think it was Fashion ID ruling, where a website, I think they found that a website operator can be a joint controller with a third party. I think that was Facebook, simply through the act of embedding a social plugin that transmits data. They didn't receive that data themselves. They didn't process it. But because they enabled that collection, because they included it on the page, that made them liable for that. And I think that that principle there applies directly to advertising pixels. But that's not the whole story there. The pixel vendor there does have some responsibility too. If they're also processing that data beyond what's contractually agreed, then that's a breach from their side. If Meta's automatic events feature is capturing payment card data by default, that's a design choice that they made. But when your user's data is exposed, a regulator's first question is going to be directed at you. What did you know about it? Why is that running on your site? What did you do to try to control it? And if the answer there is, we didn't know we had that, that's not really a good defense. So, kind of tying it back, I think the audit steps that I discussed really do matter here.
Mhm.
You need to know technically what's happening in the browser, not just what your vendor agreements say should be happening. So that's kind of the gap there where that regulatory risk lives.
Yes. And I think one more before we run out of time. How does this maturity model account for zero persistence or ephemeral processing? If we use a system that anonymizes and purges raw telemetry at the source, does that essentially skip the storage risks entirely and moves us straight to the analytics and value layers?
Yeah, quite possibly. I think that sort of zero persistence and ephemeral processing where you are anonymizing things, that's really good. But I'd also be wondering where that anonymization takes place. I've seen it take place in the browser, so the actual script or the pixel that's running in the page is anonymizing it at that point before it's being transmitted. That's a much better place to do that, because at that point, no organization is receiving that data. That's a really good position to be in. I'd maybe be wary of things like the de-anonymization of that data, but if you can demonstrate that de-anonymization doesn't really factor in, great. If that anonymization takes place once you've received it, once you're the ones processing it, that's a little bit different, because at that point you have received the data, and yes, the controls that you're putting around it do make that storage part much more straightforward, much safer. But the risk level is going to be that little bit higher. I always like to think about this from kind of an attacker's perspective. It's not what are they doing, it's what could they do. So if an attacker maybe got onto your systems and now we're able to see that data that was being received, that's a higher risk than if you're first receiving data in an anonymized form. So I'd really want to kind of dig into that question a little bit more to understand exactly what it is, where that data is being anonymized, how it's being anonymized, what you're doing to try to prevent it from being de-anonymized as well. So I hope that answered that question.
And we have 2 minutes left, maybe time for one more. Most organizations already have a CMP in place recording user consent. How does Jscrambler actually verify at runtime that third-party scripts are honoring that consent? And what actually happens when Jscrambler detects a violation?
Okay, yeah, interesting question. So what web page integrity does is it runs in the browser along with all of those other scripts, and it hooks in kind of before those scripts run, and it's then able to observe everything that they're doing. So it will see the loading of those scripts, it will see the CMP being loaded, it'll see other scripts being loaded as well. And what you can do is you can actually just look at the types of data that are being sent. So we're not capturing the actual data that's being sent, we're capturing telemetry about it. So if a CMP is blocking certain scripts from running, then you would not expect to see that running in 100% of sessions. You'd see it in fewer sessions. If you're doing things like A/B testing, you're going to have the same kind of issue where you're seeing a certain percentage of scripts running or not running. But it also gives you the ability to see exact clear telemetry of when the scripts are running and so on. So you can kind of tie it back. Second part of your question, what happens when we detect a violation? So we have a dashboard where you can see all of this information in real time, but equally we're also integrating with any systems that you have. So if you've got log management, SIM systems, those types of things, we can integrate with those to send you real-time alerting anytime that we detect a violation too. Okay.
Thank you, Gareth. And now I think we will go back to Selena.
Thank you so much. Thank you to Gareth for sharing these incredibly valuable insights with us. Thank you to Jscrambler for sponsoring today's program so that it is free for our audience. Just a reminder that the recording and the slides of today's program will be made available on the IAPP website under the Resources tab within about 48 hours. Thank you all again so much for joining us, and we hope to see you in another IAPP web conference soon.